Alright, let's talk about Secure Boot. In this video, my goal is to enable Secure Boot on my system. But why do I need it? Well, for the sake of having it, really. There's for like a computer, especially a PC that sits at your home. Uh, I don't believe in a lot of security shit because it just makes a lot of stuff annoying. Like if somebody is at your house, then like it's already over for you anyway. So secure boot is not going to save you. Maybe on your laptops, this would be more useful. So somebody would steal it, and then he wouldn't be able to boot anything on your system because you have secure boot enabled. But I'm not a security expert, and I want to enable secure boot using my own keys. So this is not your standard just going into the UEFI settings and just checking secure boot on. I want to enroll my own keys, sign the kernel myself, and then later, using the knowledge from this, I believe I have not tested it. It is also possible to, let's say, modify or authorize modifications of, let's say, other kernels. So, for example, if you want some kernel cheats for Windows, I don't know, you want to cheat in Counter-Strike and you would enable some cheats in the kernel as kernel modules on Windows, I think it would be possible to just authorize them because you would have still secure boot enabled, but with a bogus kernel. But yeah, so I want to be using this article as the, let's say, uh, reference for what I will be doing, because I'm using Grab. Technically, in my setup, you don't need Grab, but the problem is that pretty much all UEFI boot menus suck and they look horrendously ugly. And so using Grab just makes the boot menu look good. And yeah, but the problem is that this article talks about manually configured and compiled kernel, which I'm not going to do because it's annoying. Like the Gentoo kernel, like the package from Portage is pretty good. And with default settings, it's even better. Normally, also the binary kernel is nice, but with the binary kernel, I don't think you can sign the modules, which we will be needing. Which we will need to sign the modules. All right. Then there is this understanding the boot chain. So if you really want, you can read the entire article, but it doesn't. It helps, but later you have to be doing your own thinking to set it up. So let's talk about this graph quickly. So we have UEFI, and then it has the keys and the signatures and the platform keys, the keg, and whatever random secure boot stuff needs. Again, I don't fully understand it, but I know what I'm doing roughly, and it's been proven to work. So I'm doing it again here on this new fresh install of Gentoo and fresh install of everything on this computer actually. So then UEFI boots into Grab. So Grab is an FE executable. It's like a system, let's say. So UEFI boots it, so it has to verify that the Grab is correct. It's the Grab you have authorized, and if that's true, then Grab is booted. And then Grab does some more. So in my graph, this kernel and the init.rmfs and the microcode, this is a unified kernel image. So it's like a one block. So it's much simpler. I have actually the graph here. So once you boot into Grab, Grab, let's say, chain loads the kernel image. And how does it do it? So it first checks with GPG the signature. So Grab has its own signature verification, which checks the kernel image if it's correct, and then if it finds it, it tries to chain load it. But to chain load, if you want to chain load an image, it's also another FE executable, and so UEFI also needs to authorize that another executable to run. And then if you run the UKI and you have mod sign, as I've written, but you basically have module verification, so kernel modules are also signed, then you are happy and you have a nice secure boot system which is working. So the goal, so we are starting with secure boot off in the UEFI system. And then the goal for this video, let me choose red, is to take out these keys from UEFI. So these are by default installed by the manufacturer. If you have a modern UEFI, then it's a bit of a bummer because you need to merge those keys with your new ones, because you might break your system. Because modern systems use option ROMs or whatever it's called, and if you use secure boot, you also need to authorize those option ROMs, because they are separate executables, which I mean is nice. It makes the software stack much more modular on your computer, but I don't know where to find like exact documentation on those and how to sign them with my own key. So it's a trade-off really. So sometimes you don't want to remove them, you want to merge them, but I know that on this system I can nuke them from my UEFI and install new ones. So the goal is to nuke those and install new ones in their place. Then I need to, using the new keys, sign grab, sign the UKI, then also sign the modules with the mod sign, so back here. And then also use GPG to sign this and other files related to grab. And then when that's done, I can enable secure boot and have a happy face because secure boot is working. And I don't know why would I need secure boot really, but yeah, I feel more secure. Let's say no vulgar will come to my house and boot Arch Linux on my computer then. So that's nice. Alright, so let's start the setup. So the first thing you want to edit make config. So if we go to make.conf, we want to enable secure boot and modules sign. This will basically enable secure boot and module sign on everything which it supports, on everything which supports secure boot and supports module signatures. So this is the first step, and we can check by trying to image the kernel again. So you can see here, when we image the kernel with those use flags, then we can sign the modules and secure boot is enabled, but that's just for the kernel. So we need some extra steps. So now I will go to my kernel use flags and grab and disable secure boot in grab. Why? Because grab with secure boot installs a shim pre-signed, I don't know, executable signed with shim. So this is used for the other kind of secure boot where you don't enroll your own keys. You use the UEFI manufacturer keys, the pre-installed ones. But we don't need it, so I will just disable secure boot on grab. We will sign grab ourselves. Then let's talk also while we're here on the setup that I'm running. So I'm running a unified kernel image generated with Dracat. So that means I basically install the kernel, then I have Dracat generate me an UKI, and then it's installed to the ESP, so the FE system partition, and then grab finds that UKI and puts it in the config, and then when I boot my computer, I can select that UKI in the grab menu. So that's what we have. So we just need to add the signature verification in this moment. So with the secure boot disabled on grab, we need to image some tools. So these are given here in the article. So these are SB sign tools. And FE tools. So let's image this. I already have them on my system. I don't know why, but yeah, let's get them. All right, and so for the first part, you can actually follow the article for key creation. So here it explains what is DPK, KEK, and DB and DBX, what you need it for, and I will basically do these key generations without the combining with the factory keys. And then I will turn on the recording once we can install them to the UEFI. So as this article says, now to install, we need to put the system in setup mode. So this means that you need to disable secure boot if you haven't already, and then clear all the keys. So we need to pretty much disable all keys, remove them, nuke them, wipe them. But let's check if we can, if we have them. So no, we have a lot of keys installed from the manufacturer. So I have an ASRock motherboard, and so the PK is from ASRock. Then we have KEX from Microsoft. We are not in setup mode. So now the goal is to remove all those keys. So I have to boot into UEFI and basically do that. I don't really have a way to record. So you will have to believe what I did. Alright, so this is already done. So you can see no entries in the platform key, key exchange key, database, and there is also the mock list. It's also here. So now you would install the keys, but there's one more step which is not mentioned on Gentoo because no normal Gentoo users also use Windows, but our fellow Arch users do. And to have Windows, I recommend also reading this. This is in the Secure Boot article on ArchWiki. You can read this all, but basically you need to install a few Microsoft keys which are used to Saint Windows. What's problematic slightly, so you can read here on actual security of this and how to make it secure. Basically, this is not very secure because Microsoft can sign anything, and if you have a tinfoil hat, you can say that okay, so Microsoft can break into your house, sign a key, sign some virus with this key, and then plug it in and install it on your computer. So you don't need to do this if you don't use Windows. And if you use Windows, then I think your tinfoil hat has some holes already because you use Windows. So yeah, I will have to download those keys and get them and make them into FE signature lists. So how they say here, so this is using SP sign tools. So you basically create a signature list from the certificates, and then they concatenate them all into one. And then the same they do for the kek. And then here it's a little different than on Gentoo because Arch uses a separate key and a separate certificate. We use PEM keys, PEM certificates from OpenSSL. So this is just one kek.pem and kek.pem for the certificate. And then everything here is the same. And then when you enroll, so that would be here. So you update var with your keys, and then you can append the other ones. So that's not a problem. You can also like append the DB FE signature lists. So these Microsoft signature lists, you can concatenate them with your own ones and then install them all at once. This is also an option, but I think I will append. So if we do FE, what was it? Update var, and we check, then you can append. I don't know how this works with. Yeah, you would need a secret key file for authorizing user mode updates. So until you install the platform key, I think you can do anything. But well, uh, we will see when I get to this. I was always concatenating those signature lists, but well, let's see what happens if you don't. So let me just quickly download all these, and I have to make the ESLs. Okay, so this is done. Quite weird that yeah, the timestamp is never. I don't know what happened, but well, it happened. Hopefully this will work. So what this does, we specify the GUID, so the signature owner ID, to be the Microsoft ID, so that well maybe the UEFI will display these as Microsoft keys. Then we do append. So probably now if we do this command to update the variables, we will get yeah we if we get these variables, we will be able then to append the Microsoft ones. So we can, I think we can do this command, and I have to correct because I've changed the name. And this enrolls the keys. So if we do FE read var, we have my platform key, my kek, my DB, and my DBX. And then I can safely, I hope, safely, I don't know, we can do FE update var. Let's see what options we have. So we can append. I don't know if we need the key. I think we are already in user mode because we have enrolled the platform key. But well, let's see what happens. So FE. So operation not permitted. So we have to use the authorization key. So probably this will be pk.pem. Okay, so operation not permitted still. So this time I don't know what to do. Unfortunate. So yeah, so back to the UEFI. I have to clear the keys and I will have to concatenate the FE signature lists and then sign them together with the Microsoft ones. So yeah, so that will take a while. All right, so after banging my head into the wall, I don't know, the srog BIOS got bugged. I don't know what happened. But I managed to put myself back into setup mode. So now we first need to concatenate the keys. So we just use cat as in concatenate, and we just db.esl with Microsoft DB into combined DB. And the same for the kek. So I hope this is okay, but well, we'll see. So now we have to sign those keys. So let me just boop. And so I've done that before, but now you need to basically create the auth files, whatever they are. They are probably signatures or something. So we use the platform key, so PK, to sign the platform key and the kek, so the key exchange key. And so yeah. So yeah, the PK and kek are now signed, so we can have the combined kek auth. And now we use the keks, the kek, whatever, to sign the DB keys, so the database. So if you now check, we have the combined database authentication, combined kek, and then dbx and pk. And what we need to basically enroll them in order. So I think that maybe it will be easier if we just move the combined db auth to db.auth back and move the combined kek auth to kek auth. So now we can use this command here from the wiki. Of course, change the my. Well, let's leave it like that. And now if you do fe readvar, we have my platform key, so just one, then kek list 0, which is my kek, kek list 1, which is the Microsoft 2011 kek, and Microsoft 2023 kek. Then if we go further, we have MyDB, which and then we have the list 1 and list 2 for the DB, list 3 and 4, which are the Microsoft. Okay, in the next step, we have to set up a grab and GNU PG keys for grab. So there is like this warning, no protection, blah 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 blah. But what basically this is, it's the same as with the keys, that you need to make the keys only readable as root, and the root is encrypted, so you use drive encryption, which I do not use. Yeah, but this secure boot is just for the sake of having it on. It's not really for security in my case. But yeah, if you want security, you also have to do root encryption, and here they even give you a link how to do the drive encryption, disk encryption using Lux, and you know, all the shit that you also have to do. But I'm not doing this. As I've said, if someone gets physical access to my disk, then I'm already probably dead, so it doesn't matter. So yeah, we have to do the grab parameter, so it's just as easy as copying. and yeah, so this is good. So we save, and we can generate the keys. So yeah, so now we have the certificate, and we can export for later. So what this does, it just exports the key. I will talk about it sometime soon. So then we need a key for the kernel. So the kernel needs to have a module signing key to sign the modules. And so we create a new directory. We change mod, and then this tells us how to set up the kernel config for this. But by default, in the distribution kernel, this is set automatically by the e-build, so we don't have to worry about it. It's set automatically by the use flags actually. So you can again read about the security of this key, how it works like. But I will just basically copy the command and run it. Of course, change to kernel key. For some reason, I don't like prefixing like names with my, like I've seen bash scripts or whatever, to have the to have variables named my or like files here, my kernel key. Like whose else this kernel key might be if not mine. But yeah, so after this we have to set up portage. So again, those use flags. So I've already set up the secure boot and module sign use flags, but now it's about configuring the make config with the proper keys. So we copy and we go to make config, and I like to put these keys down here. So we for secure boot signing, so for FE executables, we have to use the DB key, which is authorized in the variables. So this would be the DB key. If we do FE readvar, this is exactly this variable DB, and in the DB variable we have this signature. So this is signature 0 in list 0. And basically this is what we've enrolled before. Now it is used to sign secure boot executables, EFI executables. It is used to sign FE executables, EFI, whatever. So we just tell portage that if you want to sign anything to secure boot, you use this key. Then the same goes for the module signatures. So we've used here SHA-3 512, and so we also have to do SHA-3 512, which we have, and again delete the my prefix from the kernel key. And normally now this is where we diverge, because it tells us to update world, but this is because the world update does not trigger the kernel update. So what we need is some additional setup of dracat. So if you do nano etc dracat conf.d, and we have uki. Here I've commented it out, prepared it beforehand. So you need to set up dracat to basically sign the kernel with the db key after it is installed. So not only the kernel signs its modules with the kernel key, it also needs to be signed by the db key to be able to boot. So this is where we put it, so that the Dracat, after installing the kernel, no, not after generating the UKI, we'll sign it with this key. So we save, and that should be it for the setup. So if you don't know about UKI, let me just UKI. Okay, and here in this configuration of Dracat, you can configure install kernel. This is done automatically by useflags, so you don't need to set it up that much. And then in dracat.conf you can set command line, and you can use, and then you can set the UEFI secure boot variables. Also, you need to set UEFI. Yes, this is not here, but this is in the handbook. So if we go to the main page and the Gentoo handbook, in the kernel, and if we start reading about grab, about fstab, and here about UKI, so I'm running the systemd. I'm running a systemd system. So I have the boot flag set, and then in install kernel I have dracat and UKI, and also grab, because I want to chain load the UKI from grab. And here it says to set UEFI to yes when generating an UKI with dracat. And so this is where this option comes from. So you can see fairly easy stuff. You just have to read the wiki and remember it by heart. Well, not actually, but okay. So now with this, we have to update the world with the new useflags. So emerge. I will pretend this update first to with verbose. So this is the standard command you would use for a world update, but I'm using it without updating the ebuild repository. So this should be only now affecting the programs with secure boot and modules sign useflags. Well, yeah, as you can see, only the kernel is affected, and systemd, because systemd also has secure boot, because I think this is about here when you have here a little, so you can use systemd boot, because I have the boot use flag, and probably I have also an option to use systemd boot, or I think this might also be related to the systemd install kernel. So if we do systemd and secure boot, so this is related to the install kernel. So enable kernel install, and this secure boot is probably a plugin for kernel install. So now it's all about rebuilding the kernel. So well, it will take a while on my computer. It's not a speed demon. And after that, we should be able to move to configuring grab, which, this was always the worst part of actually doing this setup with an UKI. But well, we will see how hard it will be now. I think the hardest thing was this BIOS bug. But I hope everything will go smoothly from now on. Alright, so we have the kernel installed, so we have it rebuilt, and if we go scroll up in the logs, there is like too much to scroll to the compile phase because Dracat dumps the entire file system contents of the initramfs, I think. We will just look here, and it creates the UKI and then signs it, so signing unsigned original image and creating signed UEFI image, and here in the temp directory, and later it does like some other stuff and installs this temporary UKI to the ESFE system partition. So EFI is the mount point, and then it's this EFI Linux and Gentoo version and local version. So I've modified the local version to be Gentoosh just for the sake of it. And this is how I usually name my kernels. Yes, my computers have names, my kernels have names, and surprisingly, my microcontrollers also have names. So yeah. Then, so with this signed, we are already past this and the kernel because we've just installed it, yes, with portage. So now this, yeah, so this SB sign, we don't need to sign. So what it does, it signs the, yeah, it signs the Linux executable, but we have it signed. We have an entire unified kernel image signed, so we have to do less later when installing grub. And this is what about, and now we go into the section of installing grub. So it tells us to disable shim. So shim is a way of doing secure boot without enrolling your own keys, because shim is signed with the Microsoft keys, and they just give you the binary, which later, like in some way, chain loads the kernel and makes the kernel look trusted. I don't know how it really works. Well, I don't know how to explain it well, but I know that it just loads shim. Shim is trusted, so shim later loads your kernel. Okay, so this talks about this shim block. Then you have to embed the public key to verify the signatures from the private key in grub. So this is the GPG key we have generated earlier. And then you have modules, because you need to embed some modules which need to be loaded before you can load other modules. This is how, well, grub has some modules which you can think of as programs, and before loading any module, it has to verify it. If you use secure boot, then you have to verify all the modules you load, but you need some modules before to be able to check for signatures of other modules. And so these modules PGP, gcry, SHA, and gcry RSA are needed. So this is what it tells us. And then you also need to sign it with your DB key. And they give you here a nice script, so you can read it. I have it here, so we will go to... So I have the script here. It's pretty much the same, but it's a little different. So secure boot grub sign. This signs all the necessary files with the grub signature. So what we do, we find in the boot directory. You can think of the boot directory as the grub install directory, where you have the grub configuration in a way and grub modules. And this is just some magic regex from this exact script. It's a little modified. So if you look at the script, it has the VM Linux, the init, and the microcode, and FE. I don't have them here because I use a unified kernel image, so I will not have. And also, boot is not my FE system partition. It's not my ESP, so I don't have those files there. But additionally, I also assign PNGs and the theme.txt. This is because I also want to have a grab theme. I don't want to have the dark grab, because if like it defeats the purpose of using grab if you can't have a nice theme which looks better than your UEFI boot menu. Also, we append the unified kernel images for the files to sign. So we go into FE Linux and we find the FE files to which we will be signing. And we also find Windows, so all the Windows FE executables in the Microsoft boot Windows, whatever. We also sign them so that we can boot Windows from grab. And then later this deletes the old signatures, so you can read these comments. They are very informative, and then you later just use GNU-PG to sign those files. But I think, yeah, so that's this. And then you have another script which is like down below here in automation. So it has this my install kernel, but we don't do that because this is done by Portage already. But we have my install kernel. We have the grab install function. So let's go here, and this is pretty much the same but with a little difference. So we first export the GPG public key for grab so that we can embed it later. So then we do grab install, and as I've said before, we disable shim, embed the public key which we have exported earlier, then embed some modules, then set the FE directory because it's not default, bootloader ID, and we include themes with grab. I don't know if it's like includes them in the executable or how it works, but yeah, we specify the themes, and then my theme has PNG icons which don't get copied. Because themes copies to boot this theme. So additionally, from copying, we also copy the icons if they don't exist yet. Then we remove the public key because, well, it's in temp, but I remove. And then we do secure boot sign with the, I need to modify the script. We would have had a failure. So we use the DB key to sign the grab executable here, FE grab x64, and we output it to basically overwrite grab with the signed grab executable. So this is what secure boot grab install does, and I have here secure boot grab sign. So first let's, so with all the preparation, I need to source etc profile, and I need to secure boot grab install. Okay, so we have signed the grab executable. If you go to and we go to grab, we have grab x64fe. We can also sb verify if it's signed. So yeah, so we can do sb verify So we can use our DB key to verify that grab is indeed signed. We can also check Linux. So if we go to here, and also signature verification, okay. And yeah, we cannot check Windows because Windows uses a different DB key. I do not have that key. No, I think I have, but I don't want to waste time on that. So you can see that Linux is signed. So then we can do secure boot grab sign. So this basically did the signatures. So now if you look at, for example, fe grab and this directory, this directory does not, we don't sign the grab executable itself, but we can sign Gentoo, the kernel image, and you can see we have the signature next to the EFI image, and the same probably if we go to FE Microsoft boot. Yeah, if you go here, then you can see that secure boot recovery, even this, so all Microsoft EFI executables are signed. So with this, I think now it's all to reboot, enable secure boot. So we'll see then what happens. So I hope this will work. It was very very smooth apart from the BIOS bug, but well, let's restart and see if we have secure boot. Now we can take a look also dmask grab secure. So we don't have secure boot. I think it's like this. Yeah, secure boot disabled. But next boot I should have it enabled. So we will see. Okay, so at last we are back and we can verify. So we can do and this time secure boot is enabled. So that would be it for secure boot. Where to go next? So if you want secure boot just for I don't know, the sake of having it, that's it, that's all. That's what you can do in Gentoo, and well, the process is quite easy, I would say. It's nothing complicated. It's just a little scary if you don't know what you're doing. And you can also, like if you have some problems with Windows 11 and secure boot, so then you can definitely do this. Although for Windows 11, I recommend using Rufus and just disabling the need for secure boot if you don't want it, and also disable BitLocker and whatnot. Although, you know, it's up to you. Yes, you choose your own security. I don't want drive encryption. I could technically add drive encryption to this, and this setup would be quite decent because, as was stated in the Gentoo article, that you need to you store your keys without a password. They are only accessible to the root user. But to make it secure, you have to have encrypted root. And with root encryption, the process of like installing becomes a little more difficult. And I actually don't know how to do this. I have never done it, and I probably never will do this, although never say never. Maybe next week I will already do this out of curiosity. And one last thing, something which I've omitted, but it was also not visible in the video. So we can go to etc grab.d, and if we list all the files, we have the 05 UKI, which is shipped with grab, which is shipped with Gentoo. But I've replaced it with the custom UKI script. So let's quickly take a look. What's the difference? So I will show the custom UKI script, and it's pretty much like from Gentoo. But the only change I have done is in this it's here. So in the loop responsible for generating the menu options, the entry ID. So the entry ID is the first part of the kernel name. So in my case, it is Gentoo. In other would be different. Also could be Linux just. And I basically do the check if this entry ID is Gentoo. I put a nice name for it instead of just having Gentoo. And I just mark it as an UKI. And well, that's the only modification I did, just to have the menu look better, and then it creates the Linux entry with this name, so the entry ID is passed, and all the other stuff with this name instead of just Gentoo. So yeah. So that's it for this video. I hope it was helpful. I hope you could learn something, or if not, then you had fun of me that I'm a fool.